All right. Today's class is about balancing equations. Some of you were with me since mid-March. You've done this already, but if you want a refresher, that's no problem at all. I'm all for that. For the new ones, please, I wonder if you saw my note on Schoology. I asked you to print notes that are not in your notebook. So I'm going to share them with you. They look like this. So I hope you got a chance to print them. Wait, that's not it. Where's the beginning of this? Something's missing. Is it it? Yeah. Yeah. So can I get an yes, I missed, I got it, I printed it on the chat? Can I get everybody's answer? Yes, I got it, I didn't get it. Please tell me. If not, then you'll need a paper and pencil, okay? So far I have, Abdel Hamid said I don't have a printer. Do you have a paper and pencil you can start writing? Okay, perfect. Other people, please, I'm waiting for your responses. Did you print this paper? No? Joseph, do you have a printer at home? Manoj, do you have a printer at home? Okay, so if you're able to print it like right now, that would be great. It's on Schoology. It's in the updates. It's also in the folder. Here, I'll show you. It would help immensely. Otherwise, you'll be there writing all kinds. I'll show you what it looks like. Where do you find it on Schoology? So there's two places you'll find the document and their updates. Thank you. It says here, you see, for Thursday's class, I will be going over balancing equations. Please print the sheet in the link. Is it not in your notes? And it's right here. Or in materials, a June 8th week, Chem Day Thursday, and here it is again. Okay? So I'm going to get started. Hopefully you can print it. So before I do the paper with you, I just want your attention for something, okay? So let's say, especially for the new people that haven't done this at all, there's something what we call balancing equations, okay? Where in life, in nature in general, things don't just disappear. Things don't just appear either. They're there and they're transformed and they are retransformed many times for us to be able to hold on. Okay. So they're there and they are transformed a few times to get a final result. Okay, but for example, when you burn a piece of paper and you get ashes, the ashes are there because the paper was there to begin with. The components of the paper are just reorganized to give you ashes. Okay? So for us to get ashes, we need paper and we need the oxygen from the air to make a combustion, to be able to burn the paper. And then at the end, you get ashes. Got it? It's the same with, if you want mashed potatoes, well, I need potatoes to make mashed potatoes. I don't start with apples and suddenly I have potatoes. Okay? It's all about a transformation. But for us to have the end result, the beginning, the components have to be there to start with. Okay? So a scientist will write chemical equations. Let's say, for example, I want to make salt. The example here. NaCl plus NaCl. Okay. So usually we'll represent, so let's say we have sodium plus the element of chlorine, LCl2, because in nature, chlorine is not on its own like sodium is. Okay, chlorine is always combined with another chlorine to be stable. And this will give you salt, NaCl. Okay, so if I were to use colors, see, I wanted Legos, but I realized I don't have enough pieces. I have them all here lined up. I don't have enough, so I'll just color them in. So if I use colors instead, let's do circles. And we'll color it red. Oh. Erase that one. All right, so I have Na and Cl2. Let's go with a blue circle, but two of them because it says Cl2, right? If you write it the way it's written, so Na plus Cl2.
Miss, we don't see your screen.
Oh, thank you for telling me. So the whole time I'm talking to myself. Okay, thank you. So I said Na, the sodium, I represent with a red circle. And at the end, I received, like, if I draw it the same way exact how it's written, you'll see that there's something wrong with the way it's written. I'll show you. Right here. So let's count together. How many red circles do I have on the reactant side? So just a quick reminder that reactants are on the left side and products are on the right side. Okay? So on the reactant sides, how many sodiums do I have? Like, look at the circles. I have only one. Okay. And then at the end result, I also have one. That's fine. So far, that's normal. But then look at here. I have two blue circles, but only one. And in nature, that does not happen. It's not possible. Things don't just disappear into thin air. Okay? So this means that we need to balance the equation. The way that it's written this way is wrong. We need to add numbers for this to be a proper, how do you say it, like equation, right? So if I wanted to add, if I stick with the colors here again, if I wanted to, what am I missing? I'm missing a blue circle, right? On the right side. So, and I have two circles here. So for me to add another circle here, well, I'm going to have to add another NaCl. So you can't just add it by itself. It comes in a package. So I'm going to add. Here we go. So now that's good. I have two blue circles on the right and two on the left. That's fine. Oh, but now I have another problem. Now I have two reds, but on the left I have one. So now what am I missing? What do I gotta do? What do I have to add here in order for me to have the same amount of red circles? Rachel?
Because you can't add a subscript, because that changes the element, then you have to do the coefficient of 2. So there has to be 2 Na molecules.
Yes, you have to add an extra red circle. Yes. So now I'm going to add an extra red circle right here. And now it works. Look here. On the left, I have 2 red circles. On the right, I have 2 red circles. On the left, I have 2 blue circles. And on the right, again, 2 blue circles. So what does that mean here? When I'm going to write my formula, I have to write what I see. So if I see there's 2 sodiums, I put a big 2 here. You cannot write a 2 here. This is unacceptable. In chemistry, you cannot just change the molecule completely. The only thing you can do is add molecules, but you can't just put a 2 here. This doesn't even exist, okay? The only thing you're allowed to play with are the large numbers in the front, the coefficients, okay? Not the subscripts. So I'm going to go to the paper after. You'll see what I mean. Here I have 2 chlorines. I didn't touch anything here, so that stays as is. You can put a 1. There's 1 molecule of Cl2. And here I had to add an extra one, so now I have a total of 2 NaCl. So I'm going to put a 2 right in the front. You see? And now this is a balanced equation. Okay? This means that for me to create 2 molecules of salt, I needed 2 elements of sodium and 1 element of chlorine. Yes, and it's called sodium, Michael. Okay, so let's do another, let's go back to that paper. Did you have time to print it, people? Those who had said they have a printer they can print? Anyway, print it at your own pace, no problem. But try to follow with us right now. So, on the paper it says, total of each kind of atom on the left must be equal to the total of each kind of atom on the right. I can't just, like I said a million times, things don't just create or disappear. They retransform. They transform, they rearrange to give you new products, but they are essentially from the same thing. Okay? Oh, you know what? I will use my Legos after all. I went into my son's class and my son's class. Everything's a class now. My son's room, and stole some of his Legos. So like, you see I have a green and a blue, and a green and a yellow. Sorry, got it all confused here. And whatever, just random Legos. Anything. Okay, so I have blue, green, red, and yellow. I can take them apart and make a completely different structure. See, let's say a big tower. It looks different from what it started with, but it's still made up of the same things I had before, just different rearrangement. Got it? And you guys kind of did this in grade 8. We didn't do balancing, but you did conservation of mass, where you have to like calculate the mass before and after. And same goes with balancing equation. If you have the same amount of elements before and the same amount of elements after, then the mass is conserved. You have the same. It's like these pieces of Lego. No matter I take it apart and change the look, the mass will stay the same, right? Here I completely changed the look now. Yet it's still composed of the same things. Got it? Okay. So in French, some of you learned this in French, c'est la loi de Lavoisier. Rien n'est créé, rien n'est perdu, tout se transforme. C'est ça. C'est bon? Okay. Okay, back to our paper. So here, note, you can only put big numbers in front of the element or compound. So capital, I should call this capitals. The proper name is coefficients in chemistry. We call it coefficient. The big number multiplies all the atoms that make up the element or compound. Okay. So really like a bit like algebra. If you put a 2 next to the x, well, it's now 2x. It's the same concept. So let's fill this out together. So we have unbalanced equation. The right is, if you don't have the paper, you can write this one down, this initial equation. H2 plus Cl2 give you HCl. So I make a little table here to verify. When you get used to it, you'll find that you don't really need this table. But to start with, I think it's a good idea. I recommend it. Oh, hi, Nunu. Come say hi to my friends. Look, that's my cat. Sorry, small interruption. He rarely comes when I have a class. Say hello. Hello. Tutu. You're so cute. Okay, bye. Okay. I was seizing the moment. Okay. All right, back to this. We were saying. So let's count together. And I need your input on this. Let's hear, especially the new ones that haven't done this before. I want to know here, how many reactants do I have on the left of, and then I have to count the total amount of H2 of H hydrogen. Let's hear your answers, Michael.
Is it 2?
Yes, I have 2 before. And what about on the right side in products?
You have 1.
Just 1. Yeah, very good. Continue, Michael. How many chlorines do I have on the left?
You still have 2 chlorines at the reactant side.
Yeah, and on the products?
1.
1. So you see, this is not even. They have to be equal numbers. So what I have to do, let's go back to hydrogen now. What do I have to do to the 1 to make it equal to 2? Times by what?
Could you repeat that?
So the 1 that's here, do you agree it's not equal to 2? So I have to multiply by something to make it equal to 2. 1 times?
2.
Yes, 1 times 2. And same thing here, 1 times 2. What does that mean? Here, I'll highlight it. Over here. What does that mean? Look, by when you say times 2, that means I have to put a 2 right in the front here. I have to multiply the whole molecule HCl by 2. Okay, so now once you wrote the 2 in the front of HCl, you redo the calculation. So now you look, Michael, how many reactants how many hydrogens do I have on the left?
You still have 2.
You still, because I didn't touch hydrogen on the reactant side. And now on the product side?
You have 2.
Yes, look, again, you see it says 2 here, and the 2 multiplies the entire molecule. If you want, even put parentheses like that. When you put the 2 in the front, it multiplies the entire, as if you have like invisible parentheses here. It's not just hydrogen, it's chlorine also. Look, you see here, that's why I drew this. When you say 2 HCl, it means 2 entire molecules, like blue circle with the red, blue circle with the red. Okay? Okay, now here, chlorines, how many, Michael, on the left?
2.
And how many on the right?
Still 2.
Yeah, so this is good. This means that this equation is balanced. All you had to do is put a 2 here. All right, let's do another example. I'd like to hear the input of, let's see, Abdelhamid, are you there? Oh, you can't put your audio on, eh? Okay, but you can follow with us. All right, so, oh, Taylor's here. Hi, Taylor. Taylor, for the ones who just came in, I noticed there's a few extra new people. Can you please, or if you're able to print the paper I'm displaying, it would help immensely. If you can't, then just do it on a piece of paper, all right? Okay, so Abdelhamid, let's count together. So I have, to start with, how many hydrogens on the reactant side? You can write your answer if you can't put audio on. Oh, not 1, careful, 2. Do you see the little 2 here? The little subscript 2? So the 2 here applies to hydrogen, like you see in the in the drawing, I have 1 oxygen, which is the green circle, and 2 hydrogens, which is the 2 blue circles. Got it? So now, how many hydrogens do I have again, Abdul Hamid? Yes, 2. Good. And how many on the product side? Show me your answer. 0? No, there's no such thing as 0. Okay, never put 0 in one of your answers. This doesn't, 0 means inexistent. And they all exist, trust me. Hydrogen exists very much. So no, count how many do I have hydrogens on the right side? Oh, okay. Like, look at the blue circles. Yes, 2. 2 also. Good. So far, hydrogen is okay. I don't need to do anything with hydrogen. But let's look at oxygen. Again, on the left side, how many oxygens? How many green circles? 1. How many on the right? Yes. Oh, this is the problem. So what I have to do to 1 to make it equal to 2? Abdul Hamid, what are you writing? 1 times, what do I do? Add another molecule. Yes. So 1 times 2 here. Yeah. So what does that mean? On this side, here, right here, I have to add, because look, the 2 that I added is on the reactant side. So I have to put a 2 here. 2 H2O. So, by the way, those who didn't print it and they're writing on paper, just write the main equation. H2O arrow, H2 plus O2. Don't rewrite it over and over. Just write one equation. Okay? All right. So Abdul Hamid suggested we add an extra molecule on the left. So let's count again, Abdul Hamid. How many hydrogens now do I have in total? Now pay attention that this is a good opportunity to show you. You have pretend that there's an invisible parenthesis. The 2 multiplies the entire molecule. So now you have 2 entire water molecules. Yes, good job. 4, because we did 2 times 4. And then you can even count the circles. I have 4 blue circles. Good. So now hydrogens on the reactants are 4. And how about on the right? Oh. I forgot to put a 2 here. Now what? I have how many on the product side? Abdul Hamid? Yes, 4, because I had to add a 2 here to make it equal to 4. Previously, if I left it as is, I wouldn't have these 2 circles. So this, again, wouldn't be even. For me to be even, I have to put a 2 here. Okay. And now, how many oxygens on the left in total? Yes? 2. And how many oxygens on the right? Here? Yes, 2 again. Good. This is the example we did earlier together. Let me just adjust this. So finally, the balanced equation for that one is 2H2O give 2H2 plus O2. Got it? Oh, who can tell me what type of reaction this is? Is it a synthesis or a decomposition? Let's see if you remember this. I need to see your answers on the chat. Is this a synthesis or a decomposition? Only 2 people answered. Ah, there you go. Yes, very good. Because you start big and you end with 2 smaller elements. What about the first one? Ah, what about this one? H2 plus Cl2 give HCl. Synthesis or decomposition? Yes, very good. Synthesis. Excellent. Okay. Back to this. So it's the same as what we did. So I'm just gonna go straight to the answer. I had to put a 2 in front of sodium for me to have the same amount on both sides. 2 NaCl, like that. Now they're both equal. 2 Na, 2 Na. 2 Cl2, 2 Cl. Because of the 2 that's here, it multiplies everything. Gives you 2 molecules here. Look, it may sound complicated now, but trust me, when you do a few, you'll get the hang of it. It's really like trial and error. I'm going to add molecules here and there. So I'm going to give you guys a minute. I'll give you 3 minutes to try this on your own. For those who are writing on paper, just write this molecule, this equation. Zinc plus hydrochloric acid, arrow, zinc chloride plus hydrogen. I'll give you a minute, write this down, try to solve. First, you have to figure out how many of each element do I have on both sides, and then you'll be able to play around with the numbers. Okay? Is it raining? Taylor, did you get a chance to print this? Taylor Bouja? Ben Matthew?
No, I didn't.
Oh, okay. Do you have a printer at home?
Yeah.
Okay, so what are you going to do? Are you going to print it now or later?
Probably after the call.
Okay. So it's important to check out the updates that I put. Sometimes I add like important information in there. So that was one of them, to print this paper. Okay. What about Thomas? Did you get a chance to print this paper?
Yes, I printed this.
You printed it?
Yeah.
Wonderful. Okay. So you're trying to solve now?
Yeah.
Okay.
Miss, I have a question.
Yes, sir.
It's the same thing like we did before, right? Like the counting?
Yeah.
Okay.
Yeah, so we can do it together if you like.
I'll just do one together.
Okay, one together. Perfect. That's a good idea. So you count, Thomas, how many zincs do I have on the left?
One.
What? How many on the right?
I have one also.
Okay, so I don't need to do anything so far. I don't know what else to do. What about hydrogen?
One.
And on the right?
No, you have two on the left. I meant the right.
Yeah, so there already something I have to work on.
Yeah.
Chlorine, what about here?
One.
And on the right?
Two.
So you agree that this is not balanced,
No.
right? Okay, so this means, what do I have to do now to 1 to make it equal to 2?
1 times 2.
Yeah, and same here, 1 times 2.
Okay.
So do you see, this is on the left.
Yeah.
Right? So
yeah.
I shouldn't say right, I should say correct. So we don't get confused. So this is we're doing this on the left. Look here, that means I'm going to put a big 2 right here.
Okay.
And that solves the problem for both.
Oh, okay.
It's 2 in 1 package. Because by adding a 2 here, now how many do I have, Thomas?
You have 4.
No, look here.
2?
2. Yeah. Now chlorine I have?
2.
2 also. So now everything is balanced.
Okay.
They all balance. And
right.
I didn't need to do anything here.
Because it's already balanced.
Exactly. Same here. It's fine.
Yeah, okay.
That's it. So you
right,
can leave it blank or put a 1 Doesn't matter. If you feel more comfortable to put 1, you can, but it's not necessary. It's like in algebra, if I write x is the same as 1x, but we don't really write 1x kind of thing, you know? So you want to leave it, it's fine. You don't want to, it's fine also. But not 0. 0 means it completely cancels it, and there is no 0. This doesn't exist, okay? So let's try the next one. I'll give you guys 3 minutes to... I'll give you a few minutes to try number 2. So far, guys, can you get a 5 if you understand it? A 3, so-so, and just need more practice. Sorry. Whew. It's not coronavirus, don't worry. Okay, good. All right, so that's good. Keep it up. This is more practice, the better. Okay. You know, I think I forgot to review the homework. I can do that after. The homework from Vista Learning. Oh, sorry. Joseph, there it is.
Thank you.
You're welcome. You're going to help me with that one later, eh? Olivia's here. Hello, Olivia. Did you get a chance to print this paper? It was on the update. And Mark is here. You too, Mark. Did you get a chance to print this paper? No. All right, so at least write on paper. And Olivia. Oh, I just woke up, so no, but I'll get to it after the call. Well, good morning. Wake up and smell the coffee. All right. So any volunteers to solve this problem?
Can I?
Who's this, Joseph?
No, Michael.
Michael, okay, sure.
On the left side, we have 1 for Ca,
Yeah, 1 for calcium.
1 for
Yeah.
oxygen,
Yeah,
1 for hydrogen and chlorine.
yep,
And then on the right side, it's the same thing for Ca and oxygen.
yep,
And then for hydrogen and chlorine, it's 2.
yep. Yeah, right here, the 2 here. Good. So now what?
Do we have to put a ×2 on the left side of hydrogen and chlorine?
Yes, very good. And now 1 times 2 is 2. 1 times 2 is 2. Everything's balanced. 1, 1, 1, 1, 2, 2, 2, 2. So the rest stays the same. I didn't need to touch calcium, nothing else. It was only that one. Got it? Now this is a balanced equation. We try the next one. Please stop me if I'm going too fast, guys. And I mean, some things get really complex, like the ones who came earlier in March would know. I think we did extra problems too, but in grade 9, and right now this is like considered as just the basics. And next year, even next year, I don't think it's going to go any harder than that. If you're understanding this, then you're pretty set for next year. Like between you and I, this is a grade 10 subject, and it's just your teachers asked me to review this, well, to teach it to you, so that next year things will be a little easier. Okay? Because it adds on, it doesn't stop at this. Later on in science, you do more calculation based on the equations. It's like a ratio thing. So imagine like you add on back to this problem here. If I say, now that I have the ratios, it's like 2 to 1. If I have like 20 grams, how many grams is produced on the right side of calcium chloride? So we actually use the ratios. It is there's a use for this. It's not just let's balance it and stops there. Okay? But you can, I won't rack your brain with that. You'll see that next year and even in Sec 5. And balancing will be a piece of cake. You'll see.
So.
Okay.
Miss.
Oh, yes. Rachel?
So right now we don't need to worry about the bigger equations.
Yeah, but even next year, I mean, it's really similar to what we're doing. Trust me. I don't think it's going to go much harder than this.
Because that's what I have trouble with the bigger ones, so I probably don't need to worry about it yet, is what you're saying?
No. If you find one online, send it to me, and I will try and solve it together.
Okay.
But again, you have next year to do it, and even then, like I taught grade 10, I don't remember doing all really complicated ones. Oh, Thomas? No, it's just for you. You want to send it to me to correct? I could do that. Yeah, go ahead, sure. If you want me to correct your paper, you can send it to me, no problem. Okay. Oh. All right. Let's hear Joseph. You there, Joseph?
Yes.
You want to give it a try?
Sure.
All right. How many sodiums on the left?
Na, 1.
Yep. Hydrogen?
2.
Sulfur?
I think 1. I think it's 2. Oh, wait. And then
It's
the
1.
last, yeah, and then O is 4.
Yes, excellent. Okay, on the right now.
2.
Yep.
2.
Hydrogens, yeah. Sulfur?
1. And then 4.
Good. So where is the problem?
And A.
Yep.
1 times 2.
Yep.
I think.
Oops. So because it's on the left, now what? Where do I write my 2 here?
On the left, like on Na.
Yeah.
No. Oh. Yeah.
And that's it. Now you review 2Na, 2Na, I'm good. Everything else I didn't touch. Everything else is balanced. So it looked more complicated than it is. Okay?
Okay.
Yeah. Shall we continue, guys? Number 4. I want to hear, who's on my list here? Taylor. Bonjour, Taylor. Taylor, where is she? Taylor going once, going twice, sold the next person on my list. I don't know where she went, but Julia. Oh, I don't hear you, Taylor. No, I didn't hear you. Okay, Julia, Taylor is back on. Maybe you can do the next one, Julia. Okay, Taylor, are you able to answer how many aluminums on the left? You can write your answer in the chat. Taylor? Taylor, look, aluminum, I only have one element, not two. There's no little two here at the bottom. Only one on the left. And two on the right. Two here. You see the two here? Yeah, applies to Al. Okay, Taylor, what about iron on the left side? Taylor? Taylor, pay attention to the two, the subscript. Two irons here. Where do you see one? I'm not on the right, I'm on the left right now. So two irons. On the right, I have one iron. Yes. Okay, oxygen now. How many, Taylor? Yes, 3. And on the right, 3 also. Okay, so now what? What do I have to do here to make it equal to 2? One times 2 equal 2. So look, aluminum on the left, I'm going to put a 2 here. C'est bon? And on the right, times by 2 equal 2. That means on the right, in the iron, to put a 2 here. And now you verify your answers. 2, 2, 2, 2, 3, 3. Good? How many is left in here? So I think I'm going to let you do the rest on your own. We could do one more together. I want to do a trickier one. Which one was it? The one with the lower common multiplier there. Where is it? Oh, that one, I think. Yeah. Number 7, everybody. Let's go to skip to number 7, please. Number 7. And I'd like to hear someone who has audio because it's a little difficult on the chat. Let's hear Matthew. Matthew? Matthew Skenderoglu? No audio either? My audio doesn't work either. Okay, Joseph, you have a hand up? Yes?
Yeah, yes. Can I do it?
You want to do it?
Sure.
Okay. Okay, go ahead.
2 and 2.
2 hydrogens, or what are you talking about?
Oh, yeah, 2 hydrogens.
Okay. On the right?
1, and then 3.
Yes. So now what?
I think you divide.
No. Remember that these two numbers have to be equal. Okay? So what can I do? What's a common multiplier between 2 and 3?
2 and 3.
Is it multiplier or le plus petit commun multiple? Wait, the smallest common multiplier.
So 1, like 1.
No, it's not 1. Not divider, multiplier.
Multiply.
I'll let you guys think about this one.
Miss, can I do it?
Who's this?
Chris.
Chris? Sure, Manoj, you're okay with that? Oh, William. William said times 1.5. That's really brilliant. That's actually advanced. So I'm gonna leave the decimals for another time, William, but it is a correct way to do it. You can use decimals, but I don't want to do decimals yet. That's for another lesson. Let's use the common multiplier. Chris, you want to help him?
Yeah, sure. You need to put a 2 in front of the NH.
Here?
Yeah.
Okay.
So then you're gonna have on the right, you're gonna have 2.
Yeah.
So they're gonna be equal.
Yeah.
And then on the right for H, you're gonna have 6.
No, not 6. 6 will give you 12 hydrogens.
No, I mean on the right, like you have to change a highlighted number.
Here, a 6?
No, there you keep a 2. And then for H, it's gonna be 2 on the right.
Yeah.
Oh no. Oops.
It's a tricky one. I won't give you the answer yet. But you're onto something. Look, Chris, you said I'm gonna add a 2 here. Okay, that's good. Now, count with me. How many hydrogens is that in total?
6.
So
And then
now,
you
over here, what do I put
a
in
3.
front of H?
A 3.
Yes. Ding, ding, ding. That's what I was saying. Lowest common multiplier. 6. So here, 2 times 3, and here, 3 times 2. And now this will be equal 6. Got it?
Yeah.
And then here, by timesing by 2, you get 2 nitrogens. But when you put a 2 here, it does the job for both nitrogen and hydrogen. So you're good. 2 nitrogen, 6 hydrogens. And here, 6 hydrogens, 2 nitrogen. So this is as tricky as it gets. Doesn't sometimes you'll get numbers that are odd like that. Like let's say 2 and 7. Wow, I can't exactly times 2 times something to give me 7, unless it's a decimal, which don't start yet with decimals. But this is when you do well. I can do 2 times 7 and 7 times 2, and then now that gives me 14. You could do that. Multiply each other with the number. Okay? So if you understand this problem, you put a 5. If it's so-so, put a 3 on the chat, please. I want to know, because I don't see your faces. This is what I miss the most. Yeah. I miss the most is to see your reactions. And that's how I know if I move on or stop. But because nobody turns their camera on, I can't see anyone. Okay, so we can do one more exercise together on the internet. There's some cool animations. I'm gonna let you try and finish this page on your own. There's like 4 or 5 more questions, and then we can correct it next time together. Okay. So this is an animation on it's a gizmo. And I would like to get somebody's input here. Let's see who can answer with me. Julia, are you able to unmute yourself? 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 Ju Or you just want to write on the chat? Okay, I guess you're going to write on the chat. Look how many circles I have here. Oh, you too, eh? Okay. I have one NaCl, which is a green and a purple circle. Here I have one purple, two green. So think with me, what do I have to do here? Do I have to add an extra molecule? What do I do? Tell me. What's the number I'm going to add here? Because I have two green here, only one. Julia. So here, do I multiply by 2, by 3? Do I leave it as is? What do I do? Add another purple. Not yet. I'm still on the green, Julia. If I add another purple, well, okay. If I add another purple, Julia, okay, we can start with that. I have two purple on the right and two green on the right. And now here I only have one of each. So what do I have to do up here now? Do you see it? To make it all equal on both sides. Julia? Put another green and purple. Yes, bingo. Good job. Show summary. Yeah. You get a green check mark. Very good. Okay, next person. Let's do this one. Any volunteers? Or do I choose? Oh, I hear someone. Who's there?
Can I go?
Is that Michael?
Yeah.
Michael, sure, go ahead.
Um.
Oh, let me just get back in there. There. So I'll give you a second, think about it.
Do we need to add another O on the right side, on the product side?
Another one here? Yeah. That's good. So now the red circles all are equal, 2 red circles, 2 red circles. But now something's not equal.
Oh, we need to add another H2.
Bingo. Yes, the equation is balanced. 2, 1, 2. Excellent. Very good. Let's see if the other one is not too complicated. We can do it. Anyone want to give that one a shot? Ella? I haven't heard from you today. Ella Domingo.
Hello.
Hi, Ella.
Hi.
How are you today?
I'm pretty good. How are you?
I'm good, thanks. So would you like to give this one a try?
Sure. Okay.
All right. So let's carefully look. I have 1 aluminum, 1 hydrochloric acid, 1 AlCl3, 1 H2.
Okay. Sorry, I was doing it mostly in my head up to now. I didn't have a piece of paper.
Okay.
So, sorry. So we would need 3 CLs for the right side. So we would need 3 of the HCls.
Yep. So now the 3 green circles are equal.
Yeah.
That's good.
And then since we have 3 of the H's on the left side, that means that we'll need 6 on both sides. So we'll need to put 6 HCls. We'll need how many is that? 3 H2s, and how many would that be? Sorry. And we would need 2 of the AlCl3. And then that we would need 2 Al aluminum.
Yes, very good. You see, this one was a complicated one. Rachel, if you were wondering, I need a complicated one. There you go. That's a complicated one.
This is what I mean. I get confused with big ones.
Yeah, I understand. So if ever you stumble on a complicated one like this, start with the largest molecule here. So AlCl3. So you look, okay, I have one Al, that's fine. But I have 3 chlorines and only 1. So I start by putting a 3. And then you keep working at it like this, back and forth, like what Ella did, back and forth. So this is a, yeah, I could see that happening in Sec 5, for example. It's a little more enriched.
Thank you.
You're welcome. Okay, good job, Ella. Let's see if another one not as complicated. Let's see that one. Anybody want to give it a try? Now let's hear Nathaniel. I haven't heard from you today.
Hello,
How are you today?
I'm good. How are you?
I'm good, thanks. Would you like to give this one a try?
Sure.
CH4. What just happened? Must we have problems? Oh. There. Okay. CH4 plus O2 gives CO2 plus H2O. So carbons, okay, I'll give you a minute to think about it. Yeah, those are a little more difficult. If you're just starting out, I know some of you, it's their first time doing this. Don't worry. If you're able to get through the paper I sent you, it's enough for grade 9. Okay?
So I would assume that you're doing 2 H2O as like on the last one. It would be 2.
Okay.
And then 3 of the O2 on the left side. 3.
3.
Yes.
Why 3?
Or 2, sorry. Wait. 2.
Look, how many oxygens do I have in total here?
4. So it would be 2.
Yeah,
I'm
2
sorry.
plus 2.
I miscounted.
Yeah, no problem. That's it. Bingo. So 4 red circles, 1 large black one, 1 large black one, 4 white ones, 1, 2, 3, 4 white ones also. Okay. I think we had enough of that. What do you say? I think we're good with that. But honestly, guys, those last 2 ones we did are a little more advanced. So let's just keep those for next year, okay? Again, if you went through the paper I gave you, you're fine, okay? What time is it? 10:35? Oh, class is done. What? Already? I didn't get a chance to go over any issues for facile learning. Facile learning assignment this week was. Where is it, my paper? Where's my list? Oh, it's over there. 1 second. So we had oh, it was only one, right? Okay, let's see. If you guys had any trouble with oh, last week. Yeah, I checked. Some people still didn't do their homework. Unit 1, lesson 7, 10, 11. So I've been checking and I've been sending all kinds of messages on Schoology. Okay? Because you have to understand that I need to do an assessment soon of your term. And if you don't hand in anything, what am I supposed to write? 0? And there's no 0. It's either success, no success, or unevaluated. So some of you here on this chat have not submitted many things, and so you know you don't give me a choice but to write unevaluated. So if you were failing and you're not doing anything, I have to keep you failing. I don't have a choice. I don't like to do that, but you don't give me a choice. I need to see that you're actually doing work. Okay. So the assignment of last week, were there any questions? It was unit 1, lesson 7, 10, 11. 7, 10, and 11. Is there any, you can write on the chat, is there any that you want me to go over? Because at this point, it would be long to go through all 3. But if there's any you want me to go over, please tell me on the chat. No? Like this one was chemical reactions and physical changes. This had 5 questions. All right, let's hear some of your answers for number 5. Which of the following is a chemical reaction? Blowing carbon dioxide through a straw into lime water, leading to formation of a precipitate. A wooden stick breaking in 2 pieces, ice cap melting, oil spilling. Which of these is a chemical reaction? Yes. Okay. So let's see, is anything else here that seemed a little complicated? Okay, yeah, it's not that bad. What else we have? That was lesson, unit 1, lesson 7, lesson 10, chemical equations. Oh, that's a good one. Okay, let's do number 2. 3H2O means what? Is it 3 molecules of water containing altogether 3 hydrogen, 2 oxygen? Is it 3 molecules of water containing altogether 6 hydrogen and 3 oxygen? Is it 2 molecules of water containing altogether 3 hydrogen, or 3 molecules of water containing altogether 2? Which answer would it be? Yes, is it only Michael in here that's answering? Michael and Rachel? Yes, the second one. 3 molecules of water means 3 times 2, 6 hydrogens, 3 times 1, 3 oxygens. Right here. Good. Ooh, I like this question too. Number 3. Let's hear your answers. What's this? Olivia Saad, are you still there? So what do you think, Olivia? The diagram that's there. Which of these 4? Yes, the fourth answer. Last one. Yes, good. Good. Okay. That's pretty much, it's all the same thing over and over and over.
Miss,
Yeah. Oh, there's balancing in here. Oh, there's balancing. That
Can
should have
we-
been today's homework.
can we go over the number 5? I think I got that one wrong. Oh wait, this is the one I asked you about at the revision. Oh, okay, yeah, we went over it already.
Okay. So you see, if you had trouble with this, now that I taught you about balancing, you might actually be okay doing this. So if you did really bad in that quiz, you can go back and try it again now that you learned about balancing, okay? So I'll give you guys, if you haven't done it, please work on it. What else? And then there was, the last one was unit, lesson 11, types of reactions. Oh yeah, that was last time we talked about this. But you see, on facile learning, they always add a little more than what you need. I've noticed it's not exactly everything exactly like grade 9. It's a little more than what you need. Any questions here? I'm scrolling down. You guys stop me if you need me to review anything. See, they talk about single displacement. I didn't teach you that. It's not a grade 9 subject. It's a grade 10. But it says it's single displacement. It's only one element that moves. And that's it. No, that would be double displacement. No, this is not even acid-base reaction. So in your lesson, when you watch it, all this is explained. I don't see a single displacement yet.
Actually, Miss, I have a question.
Yes, who's there?
Rachel,
Yes, go ahead.
what is the difference between a double displacement and an acid-base reaction?
So, you know, acid-base reaction is really like a subcategory. It's really like, here, let me find it. Where did it go? Right here. In acid-base reaction, you have an acid plus a base, and it always gives you salt and water.
Oh, so it
It's
always
just-
ends with salt
it's-
and water.
Yeah, it always ends up in salt and water. Exactly.
Okay, so that's how you tell the difference.
Yeah.
Because I was like, I'm not sure if it's a double displacement or an acid-base reaction because I didn't see a difference because it does the exact same thing.
It's too advanced. This one's too advanced. Like it's some questions are good, like this one. This one is a synthesis. But then you have other ones like that one that's too advanced. It's hard to find exactly questions that are just grade 9. It's like a mix of grade 9 and 10. Okay. You see this? This is not an acid base because I did not create salt and water. And there's no acid and base mixed together. This is a combustion. It's a combustion. Why? Because I have C3 plus O. Remember O2? You need oxygen to burn something. And that creates carbon dioxide and water.
Yeah, that makes so much sense. Thank you, Miss.
This one is a decomposition. You start big and you end smaller. Strangely, it's not even, what about this one? Oh, this could be single. Yeah, single displacement. Where I just have the zinc. You see, zinc took hydrogen's place. Now it's here. Zinc and chlorine, and hydrogen's on its own. So it's just one element that switched. But again, this is too enriched. Synthesis, I mean, single displacement and double displacement is too much. Block your ears. Okay. Okay, that's it for today. I think you guys worked well, and it's a lot what we did today. So next Thursday is the last Thursday. So so we can do like a giant chemistry Kahoot review. There'll be, I'm going to add, I didn't talk much about energy. There are energy questions in facile learning to do. Some of you on that chat haven't done. I'm not going to sit there and tell you which people, but I think you know who you are if you haven't done anything in Unit 10. Okay? Unit 10 is something that needs to be done before the end of June. All right? I'm going to add it. So I'm going to put it in the homework before to like, so you finish it before the end of June 23rd. Okay. June 23rd is your last day. Yeah. So I'm not going to do like another tech on the June 23rd. I think you have math. That day is their last math day, June 23rd. So for science, next week is the last week. Okay. So we'll do Tuesday, we'll do a mini test in tech. And Thursday, we'll do like a review Kahoot. I had put a while ago a self-assessment chemistry test on Schoology. I can reactivate it for those who didn't get a chance to do it. It's just for you to, you know, to know if you're on the right track or not. There isn't, in that mini test on chemistry, I didn't put anything on dilution and balancing. So I can add an extra one for those two things if you like. Would that help? Rachel, Nathaniel, Ella, the ones who've been there since the beginning. Okay, but keep checking Schoology. Do you have any questions before we log out? This is the time to ask people. We're coming to the end. You should be very happy. Good job, everybody, for keeping up with all this work. I'm very proud of you. So if there's no more questions, you know you can count on me. And I'll be there for you. These 5 words I swear to you. When you breathe, I want to be the air for you. So the point is, I'll be there for you. So just send me a message or email me and with any of your questions. Have a good day, everybody. Bye.
Bye.
Bye.